Hello and welcome. Today, we are diving into one of the most ambitious and frankly mind-bending ideas I've ever come across, a theory for a planetary network that connects human minds with AI. It's formally called collective resonance cognition, and believe me, it completely rethinks what it means to be connected.
But what does that even mean, really? You have to forget the internet as you know it. This isn't about, sending emails with your brain. We're talking about sharing the actual essence of thought and meaning on a global scale. The goal? To create a true planetary consciousness.
So, to get our heads around this massive idea, we're going to break it down. First, we'll look at the global spectral brain itself. Then we'll explore what a language of thought would even look like, and the hardware, the mind-machine interface, needed to run it. After that, we'll tackle the super important topic of safety. Then, the incredible new senses this could unlock. And finally, we'll ask, what is the future of consciousness here?
Okay, let's start with that big picture. The theory itself is called collective resonance cognition. But the ultimate goal, the thing it's all building towards, is called the global spectral brain, or the GSB for short.
Now, the key word here is resonance. See, the global spectral brain isn't just another data network. The source material actually describes it as a kind of global right hemisphere, a system built not for raw data, but for integrating perception and meaning. It's about connecting us through the literal physics of shared oscillations.
Of course, if you're going to share meaning, you first need a language. So, how in the world do you digitize something as fluid and complex as a thought? Well, the theory proposes a few fundamental building blocks to do exactly that.
It all starts with this, the R bit, which stands for resonant bit. I want you to think of it like the single fundamental atom of meaning in this whole system. It's just a tiny snapshot of a brainwave, capturing its most basic properties. It is the smallest possible piece of this new kind of data.
But, a single R bit isn't a thought any more than a single musical note is a song. So you combine them into what's called a resonant state. This is just a collection of those R bits, all playing together to form a rich, complex chord of brain activity, a single moment of thought.
And this is where it gets really clever. This is the concept of topology. So if the R bits are the notes and the resonance state is the chord, then the topology, well, that's the melody. It's the unique pattern, the fingerprint of meaning for that thought. And by extracting just this shape, the system can send pure meaning super efficiently without all the messy raw data. So the whole process is basically 3 simple steps. First, an interface would read the brain's natural oscillating activity. Second, that raw activity gets encoded into those fundamental R bits we talked about. And finally, the system would extract just that essential topology, that meaning fingerprint, to be sent out over the network.
Okay, so we've got the concept and we've got the language. But what kind of hardware would you even use to run a planetary mind? The theory actually outlines 3 core physical components.
It really boils down to 3 key pieces of tech. You've got the RBI, the Resonant Brain Interface, which is kind of like the headset that reads and writes information. Then there's the RPU, or Resonance Processing Unit. That's the processor doing all the heavy computational work. And finally, the HSM, Hyperspectral Memory, which acts as the hard drive, storing all these meaning fingerprints for the whole network.
This brings us to what is probably the single most important question of all. I mean, if you're building a system this powerful, this interconnected, how on earth do you make sure it's safe? How do you keep a global brain from crashing or worse? Well, the answer is pretty surprising. You use physics.
The core safety feature is called the physics of physics, or pop functional. The best way to think about it is as a universal safety governor for the entire network. It's like a real-time reality spell checker that is constantly making sure every single operation obeys the fundamental laws of physics, like conservation of energy. It's designed to keep the whole system stable and lawful, always. So what happens if something actually does go wrong, like you lose connection? That's when the protected exit protocol automatically kicks in. The instant an issue is detected, the system immediately and smoothly disengages the user. A gentle, soft reset waveform then brings the brain's activity right back to its normal baseline. The whole thing is designed to feel like a simple, comfortable fade-out, because neurological safety is the absolute top priority.
Okay, so if we can make it safe, what's the payoff? What's the point of all this? Well, this is where it gets really wild. The theory proposes that the global spectral brain could unlock entirely new forms of human perception, what you could honestly call super senses.
I mean, just try to imagine perceiving the world in these completely new ways. The system suggests 2 new sensory feats: With DEM, or digital electromagnetic mapping, we could actually perceive the entire electromagnetic spectrum, literally seeing things like Wi-Fi signals or feeling infrared heat. And with DOM, a digital sense of smell, we could map molecules, letting us sense complex atmospheric conditions or even sense from far away directly.
This quote from the source material just sums it up perfectly. The result is spectral sensory augmentation, the ability to feel or see abstract physical data. We're talking about a fundamental expansion of what it even means to be human.
Now I know this all sounds incredibly futuristic, like something out of a movie, but the source material doesn't just throw this theory out there. It actually lays out a concrete step-by-step engineering plan to get from here to there.
And here's the roadmap. It starts small, with simulations and lab prototypes. From there, it moves to human trials. But, and this is really important, using non-invasive surrogates, like mapping the data to sounds or images, not direct brain stimulation. Only after years of validation and getting through strict safety approvals would controlled clinical trials even be on the table. It really shows a serious safety-first approach to all this.
So we've walked through the what, the how, and the why. But this kind of technology, maybe more than any other, forces us to ask some really profound questions. It promises us this incredible expanded perception and collective intelligence, but it also challenges our deepest ideas about who we are. And that leaves us with this one final crucial thought to chew on. If we actually build a collective mind, what happens to the individual?